Alright, so we're going to be doing some test your understanding. First of all, skip this one about the hot water lab and onto the roof of this Prosper High School about 20 meters off the ground. If you jumped off the roof, how fast would you be going upon reaching ground? Hint, think about what types of energy become what types of energy, write an equation with those types of energy and solve. Does your mass affect answer? Alright, so we know that whatever energy we have in the beginning, the initial energy, will become whatever energy we have in the end. And if we're introducing thermal energy into this situation, then we would account for that. However, this does not seem to be the case. It just looks like we're jumping through the air. So if we're going from 20 meters high, because we have some kind of elevation, then that means we have some sort of gravitational potential energy, UG. And if we're trying to find out how fast we are, then that means we're dealing with kinetic energy. So there are the general conservation of energy equation for this situation. From here we can go, we know UG equals mgy, and we know K equals 1/2 mv squared. And remember, we're trying to figure out how fast we're going, so we're looking for that v right there. I'm going to write all over this problem. We have mass on both sides in each term, so that can go away. And what we're left with, get rid of that fraction. The fraction's kind of scary, so let's deal with that. Okay, so we're left with v squared equals 2gy. We'll take the square root of both sides because the problem's not asking us for v squared, it's just asking us for v. So v equals square root of 2gy. We know g to be 10, 2 times 10 is 20, and then the height is 20, so this is going to be the square root of 400. You can leave it like that, or you can plug it in your calculator to get the final answer. That's easy enough. You might be able to do that in your head of 20, and don't forget your units, meters per second. So there we go. Energy that you have in the beginning equals the energy that you have in the end. Alright, so on to this question down here. Test your understanding. Now suppose you're 50 kilograms and you jump off of the roof of, Prosper High School, 20 meters high. This time you wear a crude parachute that causes you to reach the ground going 10 meters per second. How much energy was taken away by air resistance? So now this is our first introduction into dealing with air resistance. Well, nothing's going to change. We still are going to have some energy in the beginning of the situation and then energy in the end of the situation. But this time we are going to lose some energy to the environment, right? So as we're going down, we're going to be going a lot slower than that 20 meters per second without a parachute. We know that for sure. That's what a parachute does. It catches the air, so that way it slows us down and we can land a little bit safer. But by how much? So we are looking for how much energy was taken away. Alright, so in the beginning, we have energy in the beginning, and then we have energy in the end. And the energy that's going to be taken out of the system and put into the environment is going to be in the form of thermal energy. So from the PowerPoint, we know how to account for this. We know in the beginning we have gravitational potential energy still. Put a little subscript in there of I, so that way you know this is our initial gravitational potential energy. And then we know we're going to be moving. Skipping ahead of a step, Mr. Scapetus. So we have kinetic energy, and we're going to have some kind of thermal. So that E thermal. That E thermal is what we're solving for. So all we have to do, subtract K from each side, and then substitute in our equations. So we have UGI minus K equals E therm, which is what the question asks us to find. And we know that UGI is mgy minus 1/2 mv squared. These equations, this UG equals mgy and K equals 1/2 mv squared, just practice enough to where you don't have to think about those equations. I'm not saying sit there and study these equations because I think that's kind of a wasted time, but your mind will remember these equations just by doing so many problems. So if you're doing practice problems after this and you have not yet done enough problems to where you have these two equations down and memorized, I would recommend doing a little bit more. Equals E therm. And then from here you can plug in your answers. And I have clearly run out of space, but I can put your answer here for you. 7,500. And what are the units for any kind of energy? Joules. There you go. So for our mass, remember we're using 50 kilograms. So you take that and plug it in here. Plug it in here. And then the velocity, we're going to be 10 meters per second squared, which is 150. All of that can be done probably mentally, but use your calculators for sure. That's all hard.